I got a soldering iron shipped out to me by banggood.com to show you guys and to evaluate. It's a nice little unit. It does have some limitations. I'm not a big fan of the actual iron itself or the tip that's part of the element in the iron, but it does do a pretty good job. It heats up quick. We're going to try it out and we're going to take it apart and show you the inside of it. So the unit arrived in pieces. I had to put it together, and putting it together is not a big deal. Just have to plug the element with the tip on it into the handle and plug the handle in. It does not ship with a power cord. At least the one I received did not have a power cord. Just uses a standard computer type, like an ATX 3-prong power cord. There's the tip itself. Tip has the internal element. Now, one thing I did not like about this, and I will comment about this, is I'm not a fan of the tip that was supplied, and you'll see why. It's a knife type. Now, some people may like this type of tip. It's not my favorite. So here's the power supply. It's a microprocessor controlled iron. Comes in a nice metal case. It has a grounded prong. I've checked it. It is connected to the board. Has a rotary encoder switch on it. We'll just open the tip and plug the tip in. Initially I got an error when I tried to set this thing up because I didn't have the tip set properly. So that's the tip. It comes with the iron, or with the heater attached to it, and you don't replace just the tip. You have to replace the entire heater, which might be a problem for some people. But anyway, I had a little bit of a trouble setting it here. I thought it was plugged in at this point, but actually it actually sits quite deep, and it goes right up to that line just by my finger there. You have to snap it all the way in. If you don't snap it all the way in, when you power it up, you're going to get an error like I got. We'll plug in the power cable. Again, a standard computer power cable. It'll operate anywhere from 100 to 240 volts. And I'm getting an error. Now, the reason I'm not getting an image on here is because I just turned it off. See, the switch is in, well, you'll see, it's backwards. When the switch is down, it's actually on. Of course, my first mistake on this is to think that flipping it up is on. It's actually off. Let's try turning the button down and see what happens. Okay, so now we can set the temperature here in Celsius. Okay, it appears that my error was I just wasn't pushed all the way in. I think it's hot very quick. Yeah, so that you have to really make sure that the iron is properly seated, because otherwise you're going to get that error message to tell you that it's not going to work. So let's set this thing. I wonder if this thing can be set in Fahrenheit and Celsius. And as you can see, it's heating up relatively quickly. And there we go. It's up to operating temperature now. We'll try tinning this iron and see how good solder flows onto it, which is, as you can see, it's hot. It's very hot almost immediately. This thing heated up really quick. I was quite impressed with how fast this thing took heat. Now, one thing I don't particularly like is the type of tip it's got. I guess it's good for some things, but it does not use replaceable tips. You buy the entire element and replace it. And I would imagine that there's different tips available, but this is a standard knife tip. We'll try this thing out. I'm going to try building some stuff with this iron and see how well it works. Let's just try playing around with some of the settings on here and see what we can do with some of the settings. So it's telling me the tip temperature right now, set for 380, and this is the actual temperature and feedback. If I press the button in here, where we can set the tip temperature, and we can go up to 480 degrees. So 480 is the maximum Celsius, and 150 is the coldest. I don't read Chinese, so I don't know what that says. It's telling me it's about 14 degrees in the shop here, which 13 feels about right. But I'm curious as to whether we can change this thing to read. Okay. I have no idea what that says. But there's a couple different menus here that we can go through. Looks like there's 21 menus. So I'm using Google Translate to try and figure out what these menus are so that I can figure out how to set this thing up. This is interesting. I love the translation too. Set the vegetable beast cold junction calibration. Tip management single. It's like, okay. Great translation program here. 375 Celsius is about 700 Fahrenheit, and that's typically what we solder at. So let's give this thing a try, and then we're going to take this unit apart and see what it looks like inside. I have a kit here that I got from IC Station, and I've had this for a while. They sent me this kit, this little speaker shaped like a football. They sent me this kit months ago, and then sent me an email before I built it and said, hey, you don't need to build this one because this kit is out of stock and we don't know when we're getting it back, so you can just sit on it. So perfect opportunity. We'll try building this with this new iron and see how it performs, and then we'll take this thing apart. It's a nice little simple kit, only a few parts to mount on here. Got a couple little speakers that go inside that. One thing I have noticed is, look at my little TV that displays the time, my internet sourced time clock. Yeah, it's not looking too healthy, is it? It appears to be interference coming from this power supply, because when I turn this thing off, the interference goes away. Interesting. Turn it back on, and the interference will return. So this thing's throwing out. We gotta set the temperature again here. Okay, there we go. You see, as soon as I turn that unit on, it's creating noise, which is causing interference on my little TV. Now this is just a TV. This is just receiving a signal. I've got it modulated on cable channel 17, I think, which puts it just above the FM broadcast band. But this thing's certainly throwing out noise that it's detectable just on a regular TV. I'll flick the power switch off, and there, the interference is gone. So that's my first observation. RF interference. I can see I have my schematic here and my Chinese instructions. We won't need instructions to put this thing together. We'll just start with a clean slate here. Clean off the bench. Please note, I'm not going to completely assemble this kit in this video. I'm only going to do a few connections. I just want to get a feel for this tip and confirm what I already know, that I'm not going to like it. I'll say I'm not a big fan personally of these knife edge type tips. I find it's far too easy to bridge solder connections with them. Some people like them, and maybe for some things they are okay, but I prefer a standard round tip personally. Now I'm sure you can get different tips for this, but I'm just saying the one that came with it I'm not overly impressed with. Yeah, I would definitely recommend, if you're going to buy one of these irons, get it with a conical tip or anything but this large knife type tip. This would be great for like doing wires, soldering wires together where you need to get a lot of heat into it, or larger connections, but it's a little tricky when you're dealing with small connections. It's quite easy to bridge. This is what I mean. It's really easy to bridge when you've got a tip that's the size of a, yeah. I mean, it's all too easy to mess things up when you've got a tip that's this big. And then we got to start fixing the mess ups caused by using a massive solder tip. But as I say, this could be good for some things, right? But for fine work, you typically want something a little bit smaller than this. This is so thick. This tip, it's for this type of work. This is almost unusable, and this is just through hole stuff. You would never try to do any SMD work with something this large. I mean, this is a big tip by comparison to, say, my other one, right? You can see the difference between the two. And this tip here has been on this iron, you know, this is really old, this tip. This has been on here for forever. It's probably almost 2 years old, this tip, I would think. I bought a spare for it a long time ago, and I've never had the need to use the spare. So far, for soldering quality-wise, I mean, it gets up to temperature. We'll measure the temperature too. We'll measure that, but it's hot. That's for sure. It gets up to temperature quick. It's just that I'm not a big fan of something that big. Okay, I'm going to continue to mount the parts, and I'm not going to show it here, but I'm going to mount all the parts, but I'm not going to complete this little speaker at this point. I'm just going to put all the parts on the board and put it away, and let's get into the meter. And I'm going to get into the menus, as I did spend some time on this and figure out how to get the thing into English. So let's take a look at the menus in English. After trial and error, I finally found the setting. It's in menu number 15 for the language. So how you get into it is you press and hold the button. It'll all be in Chinese to begin with, but navigate down to number 15, which will show in Chinese. Press there, and like when it's in, there we go. We're in Chinese now. So this is how we start. Okay, hold the button, and just by trial and error, I found that 15. When I was going through this last night, I went through 15 and I couldn't find it, but I was just playing around with some of the settings, and I got down to 15 and found that 15 is the language setting. So now, and the ones listed on the website, incidentally, if you look at some of the pictures on the website, it shows screenshots, but it's obviously a different firmware version in this one, because it shows like password settings on number 7, screensavers on 8, power on state is 9, number 10 is language. In this case, it's not. Here we can change. Now we can see what the settings are. So standby, we can tell what to do. Mode switch, auto or manual, right? And we can go to 10 minutes and have the, set your time. So for example, on auto, what this will do is it'll idle down your temperature of your soldering iron after it's been sitting for so many minutes to a lower temperature, so that your tip doesn't burn up. So if you've got it set, you can go as high as what, 60 minutes, Yeah, 60 minutes, anywhere from 1 minute to 60 minutes. So if you're not using it, it will cool it down. So if you set it for 10 minutes, and you can set your temperature down anywhere from 50 degrees to 300 degrees Celsius. So that way you can have the iron turned down if you so desire, or you can turn it to manual or shake or switch. And I guess in shake, how that works is if you shake the iron, it will wake it up. I think that's how that works. Anyway, it'll idle down. So that's one setting there, or you can set it to manual or auto, depending on what you want to do. Switch, I believe if you just press and hold the switch on here, it will get out of this by pressing and holding. Gotta press and hold to get out of this. There we go. So if I tap it, it'll bring the temperature up to 375, and if I tap it again, I can set my temperature, and after the 10 minutes, it'll go down to 300. And then if I want to bring the temperature back up, I just tap it and it'll come back up. If I press and hold again, that's to sleep. Boost, this is a boost setup. So if you want to boost it, you can boost your temperature up to an additional 100 degrees. So if you need something hot for a period of time, you can set it up to boost an additional whatever temperature you want. So if you've got your iron set for 300 and you hit the boost button, it'll go up to 376 for set your time here. Any length of time you want, up to 30 minutes. Press and hold. We get back here. Cold and adjust. This is for setting it up. I haven't gone through this yet. Tip. Here's where you pick the different types of tips that you can get, because there are multiple tips available. And the tip is actually printed on the side of it, so you can tell it which type of tip it will work with. So you can select which tips you're going to use. You can either turn them on or turn them off, and it will detect the tip that you've got plugged in. And it just press the button to either put an X or a check mark for the tip that you're using. Stepping. This is your temperature stepping. Password, this is for setting the thing up. You can have it set to lock, where you have to enter a password to get into the menu if you want. Screensaver, on or off. This will dim the display. Because this is an OLED screen, it could burn if it's left turned on. Buzzer, you can turn the buzzer off or on. Voltage display, that will display the voltage to the iron. Low voltage protection, so this will turn it off if the voltage is too low to the iron. Power on state, it's in sleep or standby or running, so that's when you turn the thing on. This is for a desoldering pump. If you've got a desoldering pump, if this is running an iron with a pump. There's your pump setup for how long the pump is going to run for. If you've got an iron that's got a pump built in, language, we got through that one already. Date and time. Here's where you can set your date and time on here. So I can set the date to 2019 01/15, and the time is 19. It's going to be in 24-hour time. 1909, 1910. And right now we're at we're at 1909, but we'll wait. We'll wait for 3 seconds. There we go. Now we're at the correct time. Real-time clock adjust. This is where you can adjust the clock if it's out, and that initializes it. System information. This tells you what version this is. And then initialize, that resets everything. 21 is exit. Exit, and that takes me back. Now, I didn't find any setting to switch it between Fahrenheit and Celsius. Seems like it's only working in Celsius, but that's it. So much more usable now that I can actually read what the tip temperature is. Now I just have to get me a proper tip, because this one here is not my favorite, as I've shown you guys. But I want to show you guys what's inside this power supply for this. We'll take a look. We'll tear this down, and then we're going to measure the temperature of it and see how accurate it is. So we'll remove the last of the screws here to remove the front panel on the top, expose the circuit board, and let's get a little closer look at this. Well, I didn't expect it to be a switching power supply for the iron, but that's exactly what it is. And it looks to be a DC output too, because I've got a positive and negative going to the actual iron. The brains of it are over here, and looks like all the temperature control and everything is done through the microprocessor here. Looks to be a sensor on the tip itself, and the iron positive and negative. There's a little battery down here. This is to back up all the settings, because this is a microprocessor controlled iron. There's the power supply. It's a universal adapter, so it can operate on 100, basically 100 to 240 volts. Here's our main filter capacitor, rated at 400 volts, 68 microfarad, 400 volts. So this will work on a 240 volt circuit as well. There is a fuse in the back here, and the power switch, of course. Got some isolation between the primary and the secondary. There's cutaways here to increase the distance, and a cutaway here around the optocoupler. This is for the isolation, and the optocoupler is to provide the feedback voltage to control the switching power supply, which supplies DC power up to this other board. So here's a close-up view of the construction of the control board. Yeah, this one here doesn't look to be great, but they haven't soldered in the tabs that hold the encoder switch in place. This is the rotary encoder switch, and that's not soldered. Oh, this looks to be the MOSFET that controls the iron itself. If you look at the large copper trace here going to the positive terminal. So there's the temperature control. The IC is turning on and off this MOSFET transistor, which looks like an IC, but it's actually a MOSFET. What's the number on that thing? Yeah, it looks like a TPC 8107 from this angle. That would be a TPC 8107. It's a power MOSFET. Here's the data sheet for it. So as you can see, pins 8, 7, 6, and 5 are all connected together as are 1, 2, and 3 for your source and drain, and pin 4 is the gate. So gate is right here. Gate pin 4 is gate. Your source and drain are these other pins. So that's a power MOSFET. Looks just like an IC, but it's actually just a MOSFET transistor and internal diodes and so forth. So that's the control that turns the element on and off. Some memory in here and the microprocessor. So memory, microprocessor, little buzzer. It's battery backed up. And the display is plugged in here, or I should say soldered in. This pin is not connected. It doesn't look like it's connected to anything. That's that. I mean, it looks to be okay. Some of these solder connections don't look to be don't look to be great, but I understand this thing's available in kit form as well, so I don't know whether they got somebody who's building kits and selling them here. It's not even straight. Look at the angle here between the display and the board. Yeah, real good build quality there. But hey, it's cheap, right? It's a cheap soldering iron. I think what we'll do is we're going to put this thing back together, and I'm going to go get my temperature probe, and we'll see how accurate this thing is. You can calibrate it, right? There's a calibration control. I figured this would be fun to see how much interference this thing throws on my old AM radio. Because we saw what it did on the TV, right? It's got a clock on this thing too. Okay, I don't hear any interference to my radio. Not like on my TV that's wiping it out. It's still doing it right now. I for sure thought I'd hear interference on AM radio, but doesn't seem to be doing it. How about FM? Nope. Back to our scientific measurements here. Current temperature with my wall thermometer says it's 16 degrees. This probe says it's 16 degrees Celsius, and the iron is set to 375 degrees Celsius. So let's just put the probe onto the tip and see whether it is really the correct temperature. But it's supposed to be 375, but there is a calibration. So let me check the calibration control on it. Okay, I just added a calibration factor on here by 30 degrees. We'll apply some solder on the end here and measure the temperature now and see what we're up to. So we're up to 360. We're getting there. I'm just going to adjust my calibration here again. I'll bump it up another 10. Okay, we'll see what we get up to now. There we go. Now we're right on. Okay, I'm calibrated. That makes me happy. There's a calibration setting on here. It was the tip low temperature. It probably was calibrated when it was in the Chinese language, but when I was playing around with settings, I kind of messed things up. So I've now got it back calibrated so that the display, when it shows 375 degrees on the display here, my meter is, or my temperature sensor on my meter is showing 375, just like my other iron. So I'm now calibrated for this tip. So it's fairly simple to do, and you may not need to do it out of the box, but because I was messing around with settings and I didn't really know what I was doing when it was in Chinese, I think I may have messed things up. Just for control, let's look at my other soldering iron. There's my other iron set for 375, and it's actually running at 379, so a little bit hotter. Yep, It's right in the ballpark. So my probe is accurate. But this was just a quick first look at this unit and my thoughts on it. I guess for the price, it's not bad. Link to it is in the description. If you don't mind one of these ugly chisel tips, might as well turn that thing off, and we'll just re-tin the iron here. Say it gets plenty hot enough, and it gets hot very quick. If you don't mind a chisel tip, might not be a bad unit, but I would certainly buy one with a different tip than that. I would get one with a round tip. I think if it was sold with the round tip like this, it would be a winner. But I can't say I'm crazy about the tip that comes supplied with it. Anyway, just wanted you guys to see the inside of this thing, see how it's constructed, and we tried it out. Gets the job done. Needs a different tip. Thanks for watching.